All right, so get this. You guys sent in a ton of articles about this new satellite NISAR, and it's going to like totally change how we see the planet.
Literally.
Yeah, literally. It can detect these really subtle movements like earthquakes, volcanoes, even just the ground shifting under our cities. It's kind of wild. We're going to do a deep dive into how NISAR is going to uncover all of Earth's like hidden movements.
It is fascinating how we always think of the ground we stand on as like completely still, but the reality is that Earth's surface is constantly changing, even if we can't see it.
It's like the planet has this secret life happening right under our feet. And these articles really highlight just how important these movements are. I mean, scientists have been tracking them with satellites and instruments for a while, but NISAR, this joint mission between NASA and ISRO, seems like it's going to be on another level.
Right. NISAR is going to give us so much data about these movements, scanning almost the entire planet's land and ice surfaces every 12 days.
Every 12 days, that's crazy.
It's a lot. Think about that. We could track the growth of a city, the retreat of a glacier, or the stability of a dam every 12 days.
Wow, I hadn't even thought about it like that. And I read that NISAR has some seriously special radar technology that can see through clouds and even dense vegetation. It's like the Earth's version of X-ray vision, right?
Exactly. The key is what are called synthetic aperture radar, or SAR.
SAR.
SAR, yeah. And it's actually been around for quite a while, believe it or not. It was originally developed for military reconnaissance back during the Cold War, but now we're using it to unravel the mysteries of our own planet.
That's so cool. So how does it work? The articles mentioned something about creating a sort of virtual antenna.
Yeah, it's this really clever technique where they basically use the movement of the satellite to create a much larger antenna than could actually fit on the spacecraft.
Oh, that's smart.
Yeah, by combining tons of radar pulses as the satellite moves along its orbit, SAR can generate these images with incredible detail. Imagine taking a bunch of snapshots really quickly and then stitching them together to create this huge high-resolution panorama.
Okay, that makes sense. And NISAR takes it even further by having both L-band and S-band radar. So it's like getting two totally different views of the same target, right?
Exactly. Each band has its own strength. So the longer wavelength of the L-band is better at penetrating vegetation and seeing deeper into the ground, which is super valuable for studying stuff like tectonic plate movement and even things like underground water reserves.
So what about the S-band?
The S-band has a shorter wavelength, so it gives us more detailed information about the surface, which is really useful for monitoring things like ice sheets, glaciers, and even deforestation.
So by combining the data from both bands, scientists are going to have this much more complete understanding of how the Earth behaves, from the surface all the way down to what's hidden beneath. But with all this talk about Earth's movements, I have to ask, what about earthquakes and volcanoes? Can NISAR actually predict when they're going to happen?
That's the big question, isn't it? It's important to remember that NISAR is a tool, not a crystal ball. It can't give us an exact date and time for an earthquake or a volcanic eruption, but the articles you sent do suggest that it will give us really valuable data on which areas are most at risk for these events.
So it's more about understanding the risk and identifying potential danger zones.
Exactly. The articles used a really good analogy. NISAR will show us which parts of a fault are locked, building up stress like a ticking time bomb, and which parts are slowly releasing energy.
Okay, that's kind of scary, but also really cool. So this data could actually help with things like disaster preparedness and maybe even save lives in those regions.
Absolutely. Knowing which areas are most at risk lets us focus resources on improving building codes and developing early warning systems.
That makes a lot of sense. And speaking of specific regions, the articles mention ISR's interest in the Himalayas.
Yeah, the Himalayas are incredibly active tectonically. So NISAR's data will be super important for understanding earthquake risks there, which could really impact disaster preparedness in the region.
This is amazing. But it's not all about natural disasters, right?
Yeah.
I read that this data can also be used to monitor our infrastructure.
You're right. NISAR's capabilities go way beyond just natural disasters. It'll play a key role in keeping our cities and infrastructure safe by continuously monitoring levees, dams, bridges, even buildings. We can identify those tiny shifts and potential problems before they become major issues.
Early detection and prevention, that's key, especially with something as important as infrastructure. One of the articles even talked about a scenario in San Francisco where a huge earthquake hits and they have to inspect over 1,000 miles of levees for damage. Trying to figure all that out on the ground would be a total nightmare.
It would be a nightmare, and in a situation like that, every second counts with NISAR. We could pinpoint the exact areas that need immediate attention. That kind of rapid assessment would save so much time and resources, and potentially even lives.
So it's like having a whole team of inspectors up in space constantly monitoring our infrastructure 24/7. That's incredible.
It is. And think about how much money we could save. Instead of doing all those expensive and time-consuming ground surveys, we can target our inspections using the data from NISAR.
Safe and resilient infrastructure, that's something everyone can get behind. And all of this is thanks to this incredible collaboration between NASA and ISR.
It really shows what's possible when countries work together, especially when it comes to understanding our planet and protecting everyone on it.
It's a perfect example of how we can address global challenges by working together. It really is a great example of global teamwork. So we've talked about a lot already: earthquakes, volcanoes, infrastructure, even international collaboration. But I'm still kind of curious about how this radar technology actually works. The articles called it synthetic aperture radar. Is that like the key to it all?
Yeah, that's the heart of it. Synthetic aperture radar, or SAR, is this really clever technique that uses the movement of the satellite to create a much bigger antenna than what could actually fit on it.
So it's like creating a virtual antenna that's way bigger than the actual one.
Exactly. It's like extending the reach of the antenna way beyond its physical limits, and by combining lots of radar pulses as the satellite moves along its orbit, SAR can make these super high-resolution images. It's kind of like taking a bunch of quick snapshots as the satellite flies over an area and then stitching them all together to create this huge, detailed panorama.
Okay, I think I'm getting it. And with NISAR having both L-band and S-band radar,
Yeah.
it's like having two different sets of eyes looking at the same area, right?
Exactly. Each band has its own strengths. The L-band has a longer wavelength, so it's really good at penetrating vegetation and seeing deeper into the ground,
Makes sense.
which makes it perfect for studying things like tectonic plate movement and underground water reserves.
So what about the S-band?
The S-band has a shorter wavelength, which means it gives us more detailed information about the surface, things like ice sheets, glaciers, and even deforestation patterns.
Wow. So by putting the data from both bands together, scientists will have this unbelievably clear picture of how the Earth is behaving, both on the surface and deep down below.
It's pretty amazing, and this is just the beginning. NISAR is going to pave the way for even more advanced Earth observation missions in the future.
Speaking of the future, the articles mention that NISAR is launching in early 2025. What are you most excited to see once it's up and running?
Oh, there's so much to look forward to, but I'm particularly excited about how NISAR will change our understanding of earthquakes. The data it collects will be incredibly valuable for researchers who are studying how faults behave, which will hopefully lead to better ways of predicting earthquakes.
Yeah, that would be a game changer. And with ISRO being so interested in the Himalayan plate boundary, I'm sure we'll see some groundbreaking discoveries in that region.
Absolutely. The Himalayas are a hotbed of tectonic activity, and NISAR will give us an unprecedented look into the seismic hazards there.
And it's not just about earthquakes and volcanoes. I'm also fascinated by how this technology can be used for monitoring infrastructure. Imagine being able to predict potential problems with dams and levees before they cause a disaster.
That's what's so great about this technology. It lets us move from reacting to problems to preventing them. By spotting these subtle shifts and anomalies early on, we can take steps to reduce risks and keep people safe.
The articles talked about how this data could be used to find problem areas in things like aqueducts and pipelines. That kind of targeted inspection could save a ton of money and resources down the road.
Not to mention the environmental benefits. Imagine being able to detect leaks and spills before they contaminate a whole area. NISAR has the potential to change how we manage our infrastructure and protect our natural resources.
It really does sound like a win-win for everyone. So to put it all together, NISAR is going to give us a much clearer understanding of Earth's movements, helping us understand earthquakes, volcanoes, and even the stability of our infrastructure. It's like going from a still photo of our planet to a live video feed, seeing Earth as this living, breathing system that's constantly changing.
That's a great way to put it.
And even though those changes might be small, they can have a huge impact on our lives. NISAR will let us see those changes, understand what they mean, and ultimately make better choices about how we live on and protect our planet.
You said it perfectly. It's a giant leap forward in Earth observation, and I can't wait to see what we discover.
Me too. Feels like we're right on the edge of a whole new era of understanding our planet, and who knows what other ways we'll find to use this technology in the years to come.
That's the exciting part about science. There's always more to learn, more to discover, more to understand, NISAR is opening up a whole world of possibilities, and I'm eager to see where it takes us.
It sounds like NISAR is going to keep scientists busy for a long time.
Definitely the amount of data it will generate will be a treasure trove of information, providing endless opportunities for research and new discoveries.
This deep dive has been eye-opening for me. It's amazing to see the potential of this mission. NISAR is more than just a satellite. It's a symbol of human ingenuity and our drive to understand our place in the universe.
I agree. It shows that even with all the challenges we face, we can still come together to achieve incredible things. It's a message of hope and collaboration, which is something we all need more of.
Well said. So to everyone listening, keep exploring, keep asking questions, and keep pushing the boundaries of knowledge, because that's what the deep dive is all about.
Yeah.
Yeah, it really is inspiring to see what we can do when we all work together.
So as we wrap up this deep dive into NISAR and Earth's hidden movements, is there one big takeaway you'd want our listeners to remember?
I think the most important thing is to realize that our planet is always changing. We tend to think of the ground we're standing on as solid and unchanging. But the reality is that Earth is this dynamic, constantly evolving system, and NISAR is going to give us a totally new way of looking at those changes, the ones that are happening all around us, even if we don't notice them.
It really shows how much we still don't know about our own planet, and this knowledge could have a huge impact on how we live on and protect Earth. Definitely. From understanding the risks of natural disasters to managing our infrastructure and resources in a more sustainable way, NISAR has the potential to affect so many parts of our lives.
NISAR is set to launch in early 2025, and I'm so excited to see all the amazing data it's going to collect. What are you most looking forward to?
Oh, that's a good question. There are so many possibilities, but I think what really excites me is the potential for new discoveries. We're basically opening up this whole new window into how our planet works, and who knows what we might find. It's like going on a giant scientific adventure.
It really is. And to everyone listening, we encourage you to keep exploring and keep learning about the amazing world of Earth's hidden movements. What other ways can you imagine this technology being used? The possibilities are endless.
Absolutely.
Well, it sounds like NISAR is going to be giving us a lot to talk about for years to come.
Oh, yeah, for sure.
This deep dive has been incredible, and I've learned so much about this amazing mission. Thanks for joining us.
It's been my pleasure.
And to all our listeners out there, thanks for tuning in to the Deep Dive. We'll see you next time.